Welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 230, kth smallest element in a binary search tree. So for this problem, we're given the root of a binary search tree and an integer k. Return the kth smallest value, one indexed, of all the values of the nodes in the tree. So if k is 1, we want to return the smallest element, the exact smallest element. So if you look at this tree, in example 1, the smallest element in the tree is 1. So we return 1 as our output. And so it's pretty simple to get the smallest element in the tree, the kth smallest element in the tree, if you are just looking at the tree. But how can you programmatically get the kth smallest element in the tree? Well, you can, because this is a binary search tree, and for a binary search tree, we know that for the root node, every element in the left subtree is less than the root, and every element in the right subtree is greater than the root. And it's true for every node if you look at every node. So there's a special property of a binary search tree where the in order traversal of a binary tree is always going to be in sorted order. So the inward traversal of this binary tree is going to be 1, 2, 3, 4. And so the kth smallest element is just going to be the element at index in the traversal I. It's going to be at I plus, it's basically at I minus k. So it's going to be at not I minus k, I'm sorry, but k minus 1. So k minus 1. So the element at k minus 1, if k is 1, then it's going to be at 1 minus 1, which is 0, which is going to give us this first element here, which is the correct answer. So we can use the in order traversal to give us that first thing. And if we do the in order traversal using a stack, then we can stop, we can count the I that we're at, and we can stop at k minus 1. So that is basically what we'll do. We can do an in order traversal, and we can stop at k minus 1. And so we can do that iteratively, or we can do that recursively. I'm going to do it iteratively. So let's see it coded up. Okay, so the first thing we need is we need our stack. So we're going to make a stack to do our in order traversal. So we're going to make a stack, and we're going to put our root node in it, and we're also going to put a tuple in there. So we're going to put our root node, and we're going to put whether or not we should visit this node. So we don't want to actually visit the node first, because in order traversal goes left and then the node, and visit the node, and then go right. So we're not going to visit the node first. So we're going to have our stack, and then we're going to also have our, we're going to have our I, which is going to be starting at 1, because since it's k is I is 1 index, we're going to start our I at 1. And then we're going to loop while there is something in the stack. So while stack and stack 0 or stack -1, 0, that means while there's something in the stack. And then we're going to actually, I think we need to just make this while stack. And so what we're going to do is we're going to pop our node from the stack. So we're going to call this node, and visit is equal to stack.pop. So we're going to pop our node, and so we pop our node, and if this is our if not node, then we want to continue, because we could actually be putting in something that has none in there. And so if there's nothing in the node, if it's none, then we want to continue, skip over that node. Now, if it's time to visit this node, then what we're going to do is we're going to check if k is equal to I, then we're going to return our node dot value. And if it is not equal to, if k is not equal to I, then we're going to just need to increment I, because we visited this node and it was one node in our in-order traversal. So we're going to add I plus equals 1. Now, then we're going to continue to move one to the next node. And then now we're going to add to our stack. So what we're going to do is we're going to do stack dot extend, and we're going to add on 3 things. So the first thing is we're going to, so the way the in-order traversal goes is it goes left first, then the node to visit, you visit the node, and then you go to the right. So because we are putting this in our stack, we need to put it in reverse, because we want the right thing, we want the left thing to be the first thing that comes out of the stack, so we want to be the last thing that we put into the stack. So we're going to put the right thing in the stack first. So we're going to go node.left, and we're going to say this is not to be visited yet. Then we're going to add our node, and this is to be visited now, because it goes left. This should be node.right, because we're going in reverse, so we're going backwards. So we want, that's going to be the thing on the inside of the stack, not on the top. So it's going to go right, and then the node, and then we are going to be visiting that one, and then we're going to do our node dot left. That's the thing that's going to be the first thing on the stack, and we're not yet visiting that because it's not its turn to be visited. So then that's how we do our we add our stuff to the stack. And then we want to, so we're guaranteed to, k is going to equal I at some point because we're incrementing I when we visit a node. So we're going to be returning node.value. So let's run this and see what we get. So it's giving us the right answer for the first one. So let's submit. And it was accepted. So that is how you solve that problem. This is going to run in O of n time in the worst case, because we're going to have to visit every single node if, k was the number of nodes. And so, and we are going to have to put everything on the stack. So O of n space as well. So thanks for watching, and I'll see you in the next video.